So we have one more rule that we need to talk about. And this rule is going to tell us how to find the derivative of the composition of two functions. So before we talk about the rule, I want to take a step back, right, and make sure we're all on the same page about what composition of functions is. It really is just substitution. When I talk about f composed with g, you remember that's what that funny circle there in the middle means. Really, all this is saying is what is f of g of x. So you take the g of x formula, substitute it into the f of x formula. Okay, so to take a look, we'll just run through a couple of examples here real quick, just to get everybody back up to speed. I have these two functions, f and g, and I want to know first what is f of g of x. Well, anytime I see this, the first thing I do is I rewrite it this way, because this way makes sense to me. Now it's clear exactly what I need to do. I'm going to substitute the g of x formula, that's x plus 1, into the f of x formula. So if I replace the x, there's only 1 here, right? And f of x with x plus 1. And then simplify this. That's x squared plus 2x plus 1 plus 2. So that's x squared plus 2x plus 3. That's it. That's the composition of these two functions. Now let's try it the other way. Let's do g of f of x, and it's the same thing. This is g of f of x, right? Just the order that's reversed. So f of x is x squared plus 1. And if I put that into the g of x formula, right, replace that x with x squared plus 1, I get x squared plus 1, which is x squared plus 2. And you notice they're different, right? That's an important feature, if you will, of the composition of two functions. This function composition is not commutative. If you do it in the opposite order, you may or may not get the same result. Okay, so this brings us to the calculus part of this. Well, not really the calculus yet. To use the rule that we're going to develop here, first, I need to be able to take this function h of x, right? And my ultimate goal here is I want to know what h prime is. I want to differentiate this thing. And right now I'm a little bit stuck. The only way I can do that will be by multiplying x squared plus 1 by itself 8 times, which is just not a happy thought, right? You're going to be here for a while. I need a better way, right? And the rule we're going to talk about today is going to do that. But to be able to do this, we need to be able to think of this h of x as the composition of two functions, right? When I look at this h of x, I see two functions here. I see this x squared plus 1, right? And then I see this 8th power. All right, so see what my question is asking here is I want to find two new functions, f and g, such that when I take the composition of those two functions, I get my original function h. And the goal here, right, kind of have this in the back of your mind, I'm really looking to find an f and g where f and g are both differentiable, where I can actually find f prime and g prime. If I do that, I'm going to be home free for finding h prime. Okay, so I'm going to say, look, you notice how I kind of broke this up here. I'm going to let g of x be x squared plus 1. That's a 2. You notice g of x was it is the inside function in the composition, and it's also kind of the inside function here with the original one. Then I'm going to let f of x equal kind of that outside function. I'm going to let this be x to the 8th. You can confirm this real quick now. If you look at what is f of g of x, well, that's f of x squared plus 1, which is x squared plus 1 to the 8th. It is my original function. Okay, so let me give you one here. See if you can't split this one up the same way, right? Think about kind of an inside function and an outside function. All right, so when I look at this, I see x plus 1 here on the inside, and I see a square root on the outside. So I'm going to let x plus 1 be g of x. I'm going to let this square root be f of x. Right? So g of x is going to be x plus 1. And think back to what I said previously, right? We know how to find the derivative of that. And f of x is going to be the square root of x. So you can confirm right pretty quickly here. F of g of x is f of x plus 1, which is the square root of x plus 1. That is my original function. And I can differentiate both of those. Okay. So hopefully you've got the idea now, right? Function composition, splitting up a function. Here's our rule, and I know this is one of those things when you just see it at first, it's like, wow. But it really, you'll see in practice, it's not quite as hard as messy as it looks. There's two different ways of writing this. You'll see both of them in textbooks. I prefer this one. Okay, I think it's easier to use. Okay, so this is the one I'm going to kind of talk about throughout the rest of the lecture here. And what I want you to just kind of break this down a little bit, right? First, we take our original function, and I find two functions, f and g, where their composition is the function I'm actually trying to differentiate. That's what we're doing on the last couple of slides. Then what the chain rule says is first take the derivative of g. Find g prime of x. Then find f prime of x and substitute g of x into it. Okay, so it's one thing to talk about it. It's another thing to do it. So let's see how we can differentiate h here. And this, we could do this the old-fashioned way. Right, x plus 1 squared isn't hard to multiply out. We could multiply this thing out and just use the power rule. And that's why I picked this one, because we can do it two ways. We can do it the old way that we're already comfortable with. Then we can do it the new way, right, using our chain rule, and it kind of confirm that we get the same result. All right, so let's go old school first. Right, h of x, if I multiply this out, this is x squared plus 2x plus 1. Then using our power rule, h prime of x is 2x plus 2. All right, now let's do it the other way. Let's use our chain rule. All right, first, to use the chain rule, I have to split this up. I have to have an inside function and an outside function. Right, so I'm going to let my inside function be x plus 1, and my outside function will be x squared. Right, so g of x is x plus 1. And f of x is x squared. You can confirm real quickly for yourself, f of g of x is indeed h of x. Okay, so the next thing, I know I'm going to need the derivatives of both of these, so let's do those real quick. G prime of x is 1, and f prime of x is 2x. All right, now here's what my chain rule says. My chain rule says that h of x is equal to f prime of g of x times g prime of x. All right, so let's see what that is then. F prime, g of x is x plus 1. G prime of x is 1. All right, so if I put x plus 1 into f prime, that's 2 times x plus 1 times 1. And if I distribute here to get rid of the parentheses, this is 2x plus 2. And yeah, look at that. I got exactly the same thing. It works. Right? We're getting the same answer no matter which way we do this. Okay, so how about this thing? Right? Now there's no fancy way to make our old school methods work. I got nothing I can do to differentiate this based on what we knew previously. All right, so, but I can use my chain rule. Right? I'm going to, my inside function is this x plus 1. My outside function is the square root of x. So let's let f of x, well, let's do the, sorry, I tried to keep the order consistent. Right, g of x is x plus 1, and h of x is x to the 1/2. I'm going to go ahead and just go straight to making this a fractional exponent. I know I'm going to have it that way to find its derivative. Okay, so then the derivatives of these things, g prime of x is 1, and h prime of x is 1/2 x to the negative 1/2. I'm going to leave it like that for now. Sometimes I'll simplify as we go along. Sometimes I'll just leave it and hope things get clean at the end. For now, let's just leave that the way it is. Whoa, sorry, but I got to fix my function here. Sorry, that's not h. That is f. There we go. So h prime of x, according to my chain rule, is f prime of g of x times g prime of x. All right, so that's f prime. G of x is x plus 1, and g prime of x is 1. And I'm going to substitute x plus 1 into f prime, and I get 1/2 x plus 1 to the negative 1/2 times 1. And that's almost it. Now it's just a little cleanup. I'm going to move that negative exponent down into the denominator, and this is 1/2 times the square root of x plus 1. And that's it. There's my derivative, right? That's how the chain rule works. All right, so let me give you one. Go ahead and see if you can work this one out. Obviously, this is very similar to the first one we did. And now we're back to I truly do not want to have to multiply this out, right? So go ahead and see if you can make the chain rule work here. So let's see. I'm going to let my inside function be x squared plus 1. So g of x is x squared plus 1. And I'm going to let my outside function be x to the 8th. So that's f of x is x to the 8th. So let's get the derivatives. G prime of x is 2x, and f prime of x is 8x to the 7th. All right, so now let's do the chain rule. All right, chain rule says h prime of x is f prime of g of x times g prime of x. So let's see, f prime, g of x is x squared plus 1. G prime is 2x. And let's see, put x squared plus 1 into f prime. We get 8 x squared plus 1 to the 7th times 2x. And now let's just combine the stuff outside here. This is 16x times x squared plus 1 to the 7th. Okay. For now, if you keep writing out the f's and g's to see it, that's great. Go ahead. Practice is really key here, right? When I look at this, I don't go through all these steps to find an f and g, right? I just say, look, kind of ignore the thing that's on the inside for a minute. Take the derivative of something to the 8th. Well, that's 8 times that something to the 7th. Then, kind of unignore this, right? Go back to the inside. Take the derivative of the inside part, and there you go, right? Practice, like I said, practice is key here. Once you start getting some practice in, you'll really start to see, okay, just kind of ignore the inside function, differentiate the outside one, then multiply by the derivative of the inside part. Now this one is a little more complicated, and these are things that you need to start working on identifying. Because sometimes we're going to need to apply more than one rule to get to the answer. Right? When I look at this, the first thing I notice is I have two things being multiplied together. I have this x and this x to the 4th plus 1 to the 3/2. So I'm thinking, okay, I can use the product rule there. And then when it comes time to differentiate this part, that's when I'm going to have to pull out the quotient rule. All right, so here's what this is going to look like, and I'm going to write this out maybe in a little more detail than we normally would need to at this point, just so you can see what's going on. So h prime of x. First, all I'm doing here is I'm using the product rule. It's the derivative of the first part times the second, x to the fourth plus 1 to the 3/2, plus the first part, that's the x, times the derivative of x to the fourth plus 1 to the 3/2. Okay, so this first part is easy. The derivative of x is just 1. So this whole thing is just x to the fourth plus 1 to the 3/2 plus x times, and now I have to do the derivative of this piece. This piece is going to be a chain rule situation. My inside function, that's x to the fourth plus 1. So g of x is x to the fourth plus 1. And I'm going to leave it, and let's do the derivative. I can't go sideways here because I'm out of room. So let's just do the derivative. G prime of x is 4x cubed. And then my outside function is this x to the 3/2. So f of x will be x to the 3/2, which means f prime of x is 3/2 x to the 1/2. All right, now I can do my chain rule. This is f prime of g of x times g prime of x. So this x to the fourth plus 1, this part I'm really done with. I'm just going to keep copying it over until I finish squaring away this chain rule side. So this is f prime of x to the fourth plus 1 times g prime. That's 4x to the third. So still x to the fourth plus 1 to the 3/2 plus x. Let's see. Let me bring this 4x to the third out. 4x to the third times x is 4x to the fourth. F prime of x to the fourth plus 1. That's going to be 3/2 times x to the fourth plus 1 to the 1/2. All right, so let's see. Let's keep cleaning here a little bit. This is x to the fourth plus 1 to the 3/2. And 4 times 3/2, that's 6, plus 6x to the fourth, x to the fourth plus 1 to the 1/2. Now I'm going to simplify this, and I'm going to do it in a way that may seem a little unusual. You may have never seen something factored this way before, but this is going to be an important factoring technique when we get into the next chapter and we start talking about applications of this derivative. All right, I'm going to factor an x to the fourth plus 1/2 out of this thing. All right, so I'm going to take out an x to the fourth plus 1 to the 1/2. Okay, so what's left? Well, 3/2, that's 1/2 plus 1. So what's left there is x to the fourth plus 1 to the first. It kind of, well, let me finish. Plus, when I take the x to the fourth plus 1 away from this one, all that's left is a 6x to the fourth. Now, confirm this for yourself real quick. Distribute this back into here. X to the fourth plus 1 to the 1/2 times x to the fourth plus 1 to the first. If you add the exponents together, 1/2 plus 1 is 3/2. That works. All right, so now this is x to the fourth plus 1 to the 1/2 times, let's see, I can combine the two x to the fourths. So that's 7x to the fourth plus 1. And that's it. There's my final answer. That's h prime of x. All right, so give this one a try. See what you come up with. Okay, so let's see. Here I'm going to do the chain rule first. All right, I see I've got, well, my kind of inside function here. That's that rational expression. and my outside function is this something to the fourth power. So I'm going to let g of x equal x over 1 plus x, and f of x equal x to the fourth. So what are my derivatives? Well, I'm going to be lazy. F prime is the easy one, right? F prime of x is 4x to the third. And for g prime, I have to use the quotient rule. That's going to be the bottom. That's 1 plus x times the derivative of the top. The derivative of x is 1 minus the top times the derivative of the bottom, which is also 1. Awesome. Over 1 plus x squared. All right, so this numerator, this is 1 plus x minus x. So that's actually just 1. This actually came out pretty nice. 1 over 1 plus x squared. Okay, awesome. Now I can go to my chain rule. H prime of x is f prime of g of x times g prime of x. Let's see, that's f prime of x over 1 plus x, that's g, times g prime, which is 1 over 1 plus x squared. All right, so if I take x over 1 plus x and put that into f prime, that's 4x over 1 plus x to the third times 1 over 1 plus x squared. Now let's split this up. Let's make this 4 times x to the third over 1 plus x to the third times 1 over 1 plus x squared. And now I can simplify this a little. Let's put the 4 and the x to the third on the top. 4x to the third over 1 plus x. Only add the exponents. 3 plus 2 is 5. And that's it. There's my derivative. Okay, we've seen this guy before, right? We've seen the derivative of sine of 2x before. And the way we did it before was we used a trig identity, right? We said h of x equals 2 sine x cosine x, and then we use the product rule, right? And then we use the product. Let me do that again real quick, because I want to have it to compare to, right? So we can do a comparison again. So this is 2 sine of x times the derivative of the cosine of x plus, I've got to do it the other way around, the derivative of the sine of x times cosine of x, which is, let's see, derivative, this is 2 sine of x times derivative of cosine is minus sine, plus derivative of sine is cosine times cosine of x. This is 2 minus sine squared plus cosine squared. And I remember we flipped these around. This is 2 cosine squared minus sine squared, which is 2 cosine 2x. Okay, fair amount of work, right? Let's see if our chain rule doesn't make this a little nicer. So let me split this here. And if I want to do this with the product, with the chain rule, my inside function, I lost my pen, g of x is 2x. My outside function, h of x, is sine of x. So g prime of x is 2. I see I called it h again. Sorry. That should be f. Then f prime of x is cosine of x. And the chain rule says h prime is f prime of g of x times g prime of x, which is, let's see, f prime of g of x, that's 2x. G prime of x is 2. And if I put 2 of x into f prime, look at that, I get 2 cosine of 2x. It works, right? It works. We get the same answer either way. Okay, so let me give you one, right? Try this out. Obviously, if you do a sine, we want to see if we can do a cosine, right? See what you come up with. I'm going to use the same split, right? I'm going to let g of x equal 2x and f of x equal cosine of x. So g prime is 2 and f prime is minus sine. So h prime is f prime of g of x times g prime of x. Lost it there for a second. This is f prime. Let's see. G of x is 2x. G prime is 2. So this is minus 2 sine 2x, which is kind of what we expected after the last one, I think. Okay, so I want to take a minute here, and I'll tell you, I never remember the quotient rule. Okay, I can let you in on a secret, right? I never remember the quotient rule. What I do remember is the chain rule. Okay, the chain. If we have this function, f of x equals u of x over v of x. Well, look, think of this as u of x times v of x to the negative first. Now just apply the chain rule, right? All right, we'll do the product rule first. So this is u of x times the derivative of v of x to the negative first plus v of x to the negative first times the derivative of u of x. Okay, so let's see. This is u of x, and now I'm going to use the chain rule here, right? This is negative 1 times v of x to the negative second times the derivative of v. That's v prime of x plus v of x to the negative first u prime of x. Okay, here's what I'm going to do. I'm going to factor out v of x to the negative second. All right, so if I bring out v of x to the negative second, what's left? Well, all that's left in the middle here is minus u of x v prime of x, right, plus u prime of x times v of x. And you can confirm that again. Distribute this back in. V of x to the negative second times v of x to the first is v of x to the negative first. All right, take this part, move it down to the bottom. Over v of x squared. And on the top, I'm going to rearrange. I'm going to put the positive one first, right? V of x u prime of x minus u of x v prime of x. And you can see that is our quotient rule. So this, and I know it may be a little much for you at this point, but just kind of keep that in the back of your mind. Anytime I need to know the chain rule and I can't remember who gets the subtraction, right? I just think, okay, it's the denominator to the negative first which means when I take the derivative of the denominator, that minus 1 comes out in front and becomes a minus. That's how I remember the order that this is done in. So that's it for rules. Really, this is it for differentiation. We've got the power rule, quotient rule, product rule, and chain rule. Now, we're not quite done with differentiation yet because there are a few kinds of functions that we don't know how to differentiate. Right? We can do polynomials with the power rule. We can do rational expressions with the power rule and quotient rule together. We've seen how to differentiate trig functions. We still need to do our logarithms and exponents, inverse trig functions, and what's the last one? Hyperbolic functions, which may be new to a lot of you. So once we've done that, once we've covered all of those kind of base functions, and we've got these rules that tell us what to do when we combine these functions together, we'll really be done with differentiation as a subject by itself. You'll know how to differentiate practically every function you are ever likely to come across. Right, so that's where we're going to be going in the next several lectures here.